So we are going to move on to the next type of spatial analysis that we are talking about, which is creating buffers. Okay, so this is, as we note already, are usually a prelude to further kinds of analysis. But let's go ahead and look at how it works. So we are still using the tutorial data here from the Kawartha Lakes. We've got roads, villages, nesting sites, forests. Let's say that we are, tourism is just booming in the area. We need to expand the roads to handle increased traffic. So we can actually answer the question of how land cover, ecosystems, forests, maybe even nesting sites would be affected by an expansion of the road. We can do that by creating a buffer. We'll create a buffer of a certain length on each side of all the roads in order to show us the spatial extent of a possible road expansion. So the way we will do that is by using the geoprocessing menu here. We will select buffer. Okay, so the buffer is going to create polygons around the input features we select. In this case, our input features are the roads. We are inputting the roads. We are going to assume that the expansion will be 50 meters on each side of the road. Okay. We have several options down here for how to modify this buffer. Now you all have actually already made multiple ring buffers as part of the projection assignment, so you're already experts in how to create buffers. Okay, we are only going to make single ring buffers, but we're going to explore some of these options or these parameters down here. So in the case of the road expansion, okay, we are going to choose site type full. Okay, we are assuming that the roads will be expanded on both sides, so that is what the full option gets us. There are others we'll come back to in a second. For lines, we can either go on the left side or the right side of the line. For now, we're going to do both. Some other options in terms of the shape of the buffer that's produced, the method by which we produce it. We'll set those aside for now. Another key one here is dissolve type. So for each road segment, should we preserve a single buffer or its own unique buffer, or should we dissolve all the buffers we create into one big one? For our purposes, we want to dissolve them into one big one. So we'll see what that looks like in a second. We click OK, and it starts working down here. It tells us it's working. Thing pops up, tells us it's done. We can see that here. So let's zoom in so we can clearly see what's going on with this buffer. Okay, so we zoom in and we can see that on both sides of our road we have drawn out the hypothetical widening. Let's look at what this looks like in our attribute table. So we will select this layer, look at its attribute table. We can see that because we chose the dissolve type all, we only have one shape. Okay. So we have one big polygon representing the road expansion for all road segments. Okay, so then we can actually explore what further explore. We are now enabled to look at, okay, well, what kind of impacts might this road expansion have? We can see already that the expansion overlaps, intersects with parts of some of the forests. In other cases, it does not and will not hit parts of the forest. Okay, so let's zoom back out and take a look at another kind of buffer analysis we can run. We know that we can run buffers on any kind of our vector data, lines, polygons, areas, and points. Okay, lines, polygons, and area, points. So let's move on to polygons or areas. So let's assume that we want to determine whether there are nesting sites on the edges of forests. So we assume that most of the nesting sites occur in forests. We already used our spatial query to find that out, but we want to know, are they on the edges of forests or more in the interior? Do they like hanging out on the edges where they can hunt, or do these particular birds tend to put nesting sites in more secluded, perhaps protected areas? Okay, so we can do an analysis, create a buffer that shows us, say, all the parts of all the forests that are within 200 meters of the edge. So we can create a buffer around the inside of each forest area. So let's see how we would do that. We're going to go to our geoprocessing menu and pull up the buffer menu again. And this time we are inputting our forests. Okay, because we are looking at the inside of the forest, we want to know those nesting sites. We know they're in the forest, but we want to know if they're on the inside edge of the forest. We're going to do negative 100. Okay, so we're going 100 meters in from the edge of the forest rather than 100 meters beyond the forest. Okay, in this case, we want to choose our side type to be outside only. Now, I just told you we were looking at the inside. What this means is that we are only doing one side, and because we have a negative number here, we are doing the inside. So even though it says outside, because we have a negative value here, it's actually going to build our buffer on the inside. Okay, if this was a positive value, the buffer would be only 100 meters on the outside of the edge of the forest shape. If we did full, we would have a buffer on both the inside and outside of that forest boundary. Okay, and again, we'll go ahead and dissolve all the shapes that are created. So let's see what this looks like. It's going to take a bit longer to load this time, since we have more features to work with than the road segments. Okay, and I'm going to change the visuals here so that we can see this a bit clearer. All right, so now all this lilac shape represents 100-meter buffers on the inside edge of each forest. Let's zoom in a bit closer and look at what that means. Okay, so as you can see, here's our edge, forest edge. We have a buffer 100 meters in. We could then proceed to do further analysis to understand whether we could do a spatial query to understand whether there are any nesting sites within this polygon, within this shape, representing that 100-meter boundary. We'll go ahead and open our attribute table again. Again, we dissolved it. We dissolved the buffer, so they are now just one shape. And let's zoom back out and do one more kind of analysis, one more kind of buffering, one that you might expect to be very prominent, one that you may have been expecting in the first place, and one that you've already worked with in Lab 2. We're going to buffer around a point. So we've done lines and polygons so far. Let's work on points. So let's assume we want to know. We want to know what's 100 meters around each nesting site. So if we had more detailed land cover data, we could find out using this buffer, okay, what is within 100 meters of each nesting site. So again, we'll go to buffer. We'll input this time our nesting sites. We'll say 100 meters again. Because we're working with points, our only option is to create a buffer around everything, or in all directions around a point. But we do have an option of whether or not to dissolve the buffers. So if there are buffers from two nesting sites that overlap, we can dissolve them. But we want to know something about each individual nesting site and what's around it. So we're not going to do a dissolve this time. So let's see what happens. Again, we're down here. It's running. Okay, we only did 100 meters, so it's kind of hard to see, so let's zoom in. All right, so these are 3 nesting sites. You can see that 2 of them, that 100-meter boundary buffer actually overlaps, but we did not dissolve them, so you can see that there is some overlap there. All right, and we can actually see this in our attribute table, where instead of one shape, we now have one for each nesting site. Okay, and it tells us, gives us actually the ID of the shape that we built the buffer around. Okay, the distance is 100 meters for each of them. And of course, all the areas are going to be the same because we use that same distance. So that is how we create buffers around linear, polygon, or area in point-based data.